Hello everyone. In this video, I'm going to talk about circle and its properties. A circle is a closed curve consisting of all points at an equal distance from a fixed point in the plane. And that fixed point, we call it the center of the circle. This is the center of the circle. And the length of the curve, we call it the circumference. And the fixed distance from any point on the circumference and the center, we call it the radius. And then, in choosing any point on the circumference and we join them up, this line segment AB is called the chord of the circle. And the longest chord in the circle is the diameter. Also, if a curve on the circumference runs through A and B from here to here, we call it the arc AB. And you may think that it can A can travel on the circumference from here along this longer loop to B, right? So in distinguish these two kinds of arc, we call the shorter one, that is less than the half of the circumference, as minor arc AB. And we add this symbol to specify it is an arc instead of a chord. And for the arc which is longer than half of the circumference, we call it the major arc. Okay? Now, if we join 2 points on the circumference to the center of the circle, and then we have a shape, this yellow part is called the sector, and is formed by the center O and the points on the circumference A and B. And you may also think that for sector OAB, it may be a sector as shown, or it may refer to this larger part. And so for sector, it's the same as the arc. We can have minor sector and major sector. And for segment, we first choose 2 points on the circumference and we join them up. Then the chord as well as the arc length would form a closed loop. And this part, we call it the segment of the circle. And of course, for the chord AB, it can form a closed loop together with major arc AB. And so we will have a minor segment and major segment. Okay? Now, after knowing the terms in a circle, we are going to talk about some special circles. First of all, you need to know a new term which is called the concentric circles. Concentric circles means several circles with the same center. Like this, that O is the center of C1 and O is the center of C2. The fourth, circumscribed circle, as well as circumcircle, is a circle which passes through all vertices of a polygon. And for any triangle, we must have circumcircle. And you have learned in Form 3 that the circumcenter of triangle is actually the center of the circumcircle. Okay, and in any triangle, it must have the circumcenter. So for any triangle, there must be a circle which can pass through all vertices of a triangle. And you may think of some more properties you have learned. You have learned two things. One is the formation of this center. We use the perpendicular bisector. Okay, this is the first property. And second, from the center of circle to any point on the circumference are equal. So from the circumcenter, when we join a line to any vertex of a triangle, they are of the same length. Okay? So for quadrilateral or pentagon, not all of the polygon exists a circle which passes through all vertices. Okay? And in particular, for a quadrilateral like that, that a circle can pass through all vertices of that quadrilateral, we have a special name for this kind of quadrilateral. We call it the cyclic quadrilateral. Okay? The fifth one, we call it the inscribed circle. The inscribed circle means we draw a largest circle inside a polygon. And in particular, the circle touches every side of that polygon. And inside a triangle, for this circle, we must have a center, and this center is known as the incenter. And you have learned it in Form 3 that this center is formed by the angle bisectors. So when we join from the incenter to any vertex of a triangle, the two angles are equal. Okay? The same as above, for quadrilateral, we may not have a circle drawn inside which touches all sides of that polygon. Okay, say for example, if I extend the length here, and we join here, the circle cannot be drawn larger. So for this part, it does not touch this side of the quadrilateral. But then for a triangle, it's a sure thing that the circle would touches all sides of a triangle. Okay? Now, after knowing some special circles, we come to a new world to investigate the relation of the lengths, the angles inside a circle. So the first thing you need to know is about the properties of chord of a circle. The property of a chord of a circle is that if we have a center O and we have two endpoints AB as a chord, and if we try to draw a line segment from the center to the chord, which is a perpendicular distance, and I mark this point BM. If we have a line OM which is perpendicular to AB, then something happens. If we draw OA and OB, you should find out that triangle OAM is congruent to triangle OBM, and thus we will have AM equals MB. Now, if you want to use this fact that when a line drawn from the center to the chord, which is a perpendicular line to AB, then M is the midpoint of AB. When you want to use this fact, you need to add a new reference. A reference is a geometric reason that supports your work. Okay, like angle sum of triangles, parallel lines, corresponding angles, etc. Okay, so a bunch of new references for you in these two chapters. Okay, the reference here is the perpendicular from center to chord bisects chord. For this kind of reference in these two chapters, you need to know that from the beginning is about the condition that a perpendicular line drawn from center to the chord, and the result is placed at the back. The result is bisect chords. Bisects chord. Okay, so this is the first reference that you need to know and need to remember. The second one is about the converse of the first one. The second one is something like this. If we have the center and we have two endpoints A and B, and if I mark a midpoint N here, which is known as the midpoint, if AN is equal to NB, then you should guess what's the result, right? Is that ON would be perpendicular to AB. Okay, the condition and the result is different from the first one, so the reference is different as well. Okay, the reference is line joining center to midpoint of chord, perpendicular chord. So again, the condition is placed in front and the result is placed at last. Okay, so this is the second one. Now the third one is that for the first two scenario, it involves center of circle, but then the third one, it does not involve the center of circle. The third one is something like this. If we have a chord AB and we mark a midpoint of AB known as P, and I draw a perpendicular line to AB which passes through P, like this, then guess what happens? So if there are two things, one, if AP is equal to PB, and if I mark another point like Q here, and PQ is perpendicular to AB, then the center of circle must lie on this line. Okay, so we should have O lies on the perpendicular line through P. Okay, the result is focused on the position of centers that lies on the perpendicular line drawn from P. Okay, so the reference here is the perpendicular bisector, that is the line PQ. The perpendicular bisector of chord is the condition, and the result is passes through center. Okay, so this is the third reference for you. Now it comes to the fourth one and the fifth one for this video. For the fourth one and the fifth one, they are about the same thing, but then just a reverse of the condition and the results. And it's not difficult at all. When we consider two chords like A, B, and C, D, if the two chords are of the same length, if AB is equal to CD, like this, and actually you can imagine it's a circular disc with just a rod AB here, and it can slide through the circle. So what happens to the chord AB should happen the same to the chord CD. And thus, when we draw a line from O to AB, and I mark it as M, perpendicular line, and also if I draw a perpendicular line ON, which is perpendicular to CD, then these two line segments OM and ON are of the same length. So OM is equal to ON. So what happens to A and B should happen to C and D. So the result is OM is the same as ON. Okay? And the reference to this is equal chords is a condition, and the result is equidistant from center. Okay, so for the last one, as you may guess, so that if we have two chords of unknown lengths, but if the length drawn from center to the chord, like OP and OQ, okay, if OP is equal to OQ, then you may guess what happened. The result is the chord AB is equal to CD. Okay, and the reference is chords equidistant from center. Okay, the chord equidistant from center is the condition, and the chords are equal. That means equal in length. Okay, so I introduced the first 5 references about circle to you. Is that they are about the same thing. It's about the midpoint, about the perpendicular line, and they are simple. Okay, so that's all for this video, and there are some more working examples going on related to these 5 new references. Okay, see you next time. Thanks for watching.